Hello, everybody. Hopefully, you're doing well. We're gonna start with a brand new chapter in our class, College Algebra. This chapter covered equations and inequalities. Recently, a student asked me, why do we say equations in and inequalities, but not equations and inequations? But that's just a joke, and you need to figured out why we don't say inequations, but we say inequalities. So hopefully you can leave me a message and tell me why you think we don't say inequations, but we said inequalities instead. But you know what? We're gonna start with the first section. 1.1 graphs and graphing utilities because it's much easier to use graphing utilities to graph any equations than doing it by hands. By hands, we just sketch it. So we know we have 7 sections in this chapter. So graphing and graphs and graphing utilities is the one we're gonna see in this video. Then the other sections will be covered in the next video. So graphs and graphing utilities as an objectives. Our goal, you would learn how to plot points in the rectangular coordinate system, graph equations in the rectangular coordinate system, interpret information about the graphing utilities, with rectangle or table, viewing rectangle or table, use a graph to determine intercepts and intercept information given by graph. So of course, we're gonna do all of this in just a few seconds because in order to graph, you definitely need to have some ordered pair. Or ordered pair means you have 2 points, two coordinates. That's why we call rectangular coordinates or Cartesian coordinate plane. You have two coordinates and represent inside of a parenthesis, no bracket. It's not a bracket. Inside of a parenthesis, we have two coordinates x coordinate. The first coordinate is x coordinate, and it's represented on the horizontal axis. And the second coordinate is y coordinate. It's represented on the vertical axis. So as you can see, in order to construct the rectangular coordinate system, we draw a horizontal line and a vertical line that intersects at right angles. Right angles mean 90 degrees. So at right angles, we call it origin. So that's 0. So the horizontal line is the x-axis and the vertical line is the y-axis. The point of intersection of these two axes is the 0 points known as the origin. The number line. The number line, at 0, right at the origin, but if you go to the right of 0, then you're gonna have all the positive numbers like 1, 2, 3, 4, 5, 6, 7, etc. If you go to the left of 0, it's gonna have the negative numbers like -1, -1, -2, -3, etc. Right? So, and it would be the same for the y-axis that we call y coordinates. Above 0, we're gonna have above 0, we're gonna have all the positive numbers like 1, 2, 3, 4, etc. And below 0, you're gonna have all the negative values of y. So, in order to plot a point means you have two coordinates. You see, if I said this one right here is 1 point. So that means in that rectangular coordinates you see here, if I have a point, suppose plot point A that has two coordinates. If they told me the first one is 2 and the second one is 5, for examples, let's suppose this is 1 and this is 2. So that's for x, because the first coordinate right here is x. and the second coordinate is y. And we know on the horizontal axis is x and the vertical axis is y. So we're going to count 5 for y. So that would be 1, 2, 3, 4, and 5. Now, that's not enough. We identify where those points located on the corresponding axis, but I mean where those coordinates located. Now, to make it one point, we need to find the intersection of these points. So this is where they meet. So that's where you have the point 2, 5. So the point 2, 5, as you can see, you have only one point, and that point is formed using the first coordinate as x and the second coordinate as y. Now, the rectangular coordinates, as we said, the point numbers are shown to the right of the origin, and above, that's positive, and the negative, as you can see, that's what I was trying to explain using this number. So plotting points in the rectangular coordinates as I just showed you. So each point in the rectangular coordinate system corresponds to an ordered pair, like x, y. As we said, if we have negative 3, 1, so we know x is negative 3. It's on the left of 0 on the horizontal axis, and y is 1. That means above 0 on the y-axis, on the vertical axis. So the first number in each ordered pair, as we circle, x coordinates, and the second one is called y coordinates. So if they ask us to plot those points, how would you proceed, manage to plot these points? This is x, y, x, y, x, y. Let's plot the first point, A. When x is 2, y is 4. So we need to put it right there. So this is our first point, A. Okay. And for -2, when x is 4, y is -2. Remember, those are negative, all right? So we need to put negative on in front of each of them, all right? So y is -2. This is B, okay? And when x is -3 right there, y is 0. So you see, some points fall exactly on the axis. All right. So when one of these coordinates is 0, then the point fall on the axis. So the point is located on the axis, either x or y. So if the first coordinate is 0, the point is located on the y-axis. If the second coordinate is 0, the point is located on the x-axis, right? Remember, horizontal axis is x, vertical axis is y, and the two perpendicular lines, that means they form a 90 degrees, or a right angle, that we call the intersection is called origin, or you can just put 0. So a relationship between two, I mean, we know we're gonna go very quick about it. So a relationship between two quantities can be expressed as an equation in two variables, such as, you see, y equals 4 minus x squared. So what we mean by that, anytime we see something with an equal sign, an expression with an equal sign, you remember this is an equation. Now, you have, instead of having only one variable, so you have two. We call it functions, but we're gonna see it later. So a solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain its true value. That means, for example, right there, let's suppose we have, let's verify if x is 1 and y is 3. Let's verify if these expressions right there, y equal 4 minus x squared, is true. So if we substitute y for 3, 4 minus x, we substituted for 1. Square 1 is 1 square. So we're gonna have 3 equal 4 minus 1, because 1 power 2 is 1. So 3 equal 3. We said that's true. That's a true statement, all right? So we know we can consider this statement as true. So that's an equation, right? And that's what we do. So if they ask us to graph y equal 4 minus x, we select integers for x, because we're going to talk about linear equations, but in the meantime, if you don't get that one, let's suppose we want to graph. First of all, identify the variables we have. We realize we have y and x, or x and y. So that means we can create a set of points giving values to x so we can find y. So we just plug the values of x in the original equation, so find y. But in this example, they tell us to do to take x values from -3, all right, to 3. That means each time we need to plug x equal that number to find y. For example, when x is equal -3, y would be 4 minus -3. So we agree when x equal -3, y would be 4 plus 3 is 7. So we're gonna know that would be 7. So meaning we have a first point, 3, 7, right? When x equal -2, y would be 4 minus -2. As you can see, y equal 4 plus 2 is 6. So we can say when x is -2, y is 6. So we know we have another point, -2, 6. If I continue that way, you see I can erase, and so I can do more points, because I know I'm not gonna repeat that multiple times, but for now, because we practiced our first graph, I would show you how to find the other points. So if x is equal -1, 4 minus -1, remember two negative always give you positive. That's why 4 plus 1 is 5. So x would be, oh, sorry, that's you're gonna have 5. That means -1 give us 5. And we would continue. If x is 0, y equal 4 minus 0 is 4. So you know this would be 4, 0, 4. If x is 1, y would be 4 minus 1. That's 3. 3. So that would be 1, 3. If x is 2, y would be 4 minus 2 is 2. So we know that would be 2. So that would be 2, 2. If x is 3, y would be 4 minus 3 equal 1. So that would be 3, 1. Okay. So you see at this point that examples right there tell us how to find all the points using the first coordinates, which is the x coordinates. We plug it in the original equations to find the y coordinates. Now, after you find those points, we need to plot them on the x and y axis. So let's suppose I realize in this one, I don't really have 7, because if I have 7, that would be for y, that would be 6, and that would be 7 somewhere here. So that means when x is 3, y would have a point somewhere up there. But you know what? I'm not gonna use that, because when y is -2, we're gonna have something over here. But you know what? I'm gonna take when x is -1, y is 5. Okay? When x is 0, y is 4. When x is 1, when x is 1 right there, y is 3. Yes. When x is 2, y is 2. When x is 3, y is 1. But you see, if you plug x 0, 4 minus 0 would be, if x is 4, 4 minus 4 would be 0. So you know that would fall on the axis. So because I mean, we're gonna talk about it later, but we know already this graph was going to be a straight line, because the exponent for the variable x is only 1. So, we never write power 1, but it is. So when you plug those points, it should give you a very straight line. I think my line is not straight, but you know what I mean by that. Suppose this line is straight, so it's gonna go straight until the end both ways. So when we use only x equal -3 to x equal 3, doesn't mean that's the only points you can use, all right? So you can plug x equal 100 if you want, but except you would need a big giant rectangular coordinate plane. But because it's only y power 1, only 2 points would be enough to give you the directions of your graph. Man, you know what? It's for practice. That's why we take -3, 3. Now, sometimes you can just look at an equations and know what type of shape would be your graph. When we use absolute value, and if there is no negative sign in front of your absolute value, then your graph would have a V shape. All right. The same for the previous examples, because we only have a linear functions, the graph would be only a straight line. That could be a fall from left to right or rise from left to right. It all depends of the coefficient of the x term. But here, the x term is negative. You see the graph falls from left to right. If it was 4 plus x, it was going to rise from left to right. All right. But in this case, for the absolute value functions, we know the shape of our graph would be a V, but the V would be open up because there is no negative sign in front of our absolute value term. So as we said, I don't want to use the same, if you want, I can just copy paste, but otherwise I can, if I copy only the XY plane, because I want to be a little bit lazy on, on graph, putting a graph together. But I know I need a little table where I give values to x and y. This says select integers for x equal -4 and ending to 2. So I said, as I said, in this particular examples, it is given, in this particular examples, it is asked to use a particular value for x, but not all the times. It's up to you to know which one. But they said use -4, -3, -2, -1, 0, 1, and 2. Stop at 2. When you plug -4 in these expressions, like y equal absolute value of -4 plus 1, that would give you -3. Absolute value of any number, real number, is positive. So that would be 3. Okay, because the absolute value of any negative number would be positive, or any positive number would still be positive. So I can just go -3 plus 1, -2. That gives us +2. That would give us 1. That would give us 0, 1, 2, and 3. So you see, we have something we're going to talk about later is the vortex, but where is our turning points? As you see, that's where we're going to have the V functions. So if you see when x is -4, y is 3. When x is -3, y is 2. When x is -2, y is 1. When x is -1, y is 0. But when x is 0, y is 1. Okay, we see we already form it. When x is 1, y is 2. When x is 2, y is 3. But remember at this point, we can go both sides indefinitely, right? So we can create our V term like this. Okay, so we go down and we go up. Okay, so both sides of our graph All right, so I think I messed it up a little bit over there. Let's see. I need to erase. All right, so let's suppose this line is very straight. So you know you can continue indefinitely. All right, and that is a V shape. So V shape, we plot the points and connect them. All right, so the graph is a V shape and centered at -1, 0. So the -1, that's where it's centered. So for every point X and Y on the graph, the point -x and -y is also on the graph, as you can see. All right. This shows that the absolute value of a positive number is the same as the absolute value of its opposite. Okay. Now, all right. No questions. We can talk about graphing utilities because you know, that's one of the things. Do not be concerned that we have not yet learned techniques other than plotting points for graphing such equations. You know, as you solve some of the equation in this chapter, we will display graphs simply by enhancing a visual understanding of your work. So, you know, take your time. For now, you know, think of graphs of first-degree polynomials as line, graph of a second-degree polynomials as symmetric U-shape, you know, we call parabola. All right. Now, it's important also, as we said, to know that you can use graphing utilities to plot your points, to plot your graph, or to sketch your graph. Graphing calculators and graphing software package for computers are referred as graphing utilities or graphers. Okay, so to graph any equations in X and Y using a graphing utility, enter the equations and specify the size of the viewing rectangle because you know, the most common one is TI 84 or 83 or TI 89. Myself, I have a TI 89, but some of you might feel more complicated calculator. You can use TI 92. So the size of the viewing rectangle sets minimum and maximum values for both the X axis and the Y axis. For example, if you take your TI 84, you can have some values in it like negative 10, 10, and 1. When you do negative 10, 10, and 1, so it means that the lower value you're gonna use, you know, it describes the X values, all right, on the X axis. That means what would be the minimum on the axis, what would be the maximum. So what should the smallest number you're gonna have in the largest on the axis, and what is the scale? So the second one is also for Y. So it's help you to view what we call the standard, it's the standard viewing rectangle, all right? See that on the examples, understand the viewing rectangle. So what is the meaning of negative 100, 150 by negative 100, 110 viewing rectangles, okay? So if you grab your TI 84, first thing to do is to go on window, all right, and then you see those scales. So the minimum X value is negative 100, the maximum X value is 100, and the distance between consecutive tick marks on the X axis is 50, or you can call it X scale, all right? And the minimum Y value is negative 100 and maximum 100, and the Y scale is 10. Right? There are different ways of doing this, and you know, there are different ways of doing it, and feel free to send me a message if you have if you experience a hard time to understand how to use your calculator. But I strongly advise you to use a TI 83 or TI 84. Know that for a lower versions of it, editions of it, it would be very difficult to graph, especially if you have a TI 30 or 36. It's still written scientific, but you cannot graph from that one. Um, intercepts. Intercepts, have you ever heard about intercepts? So intercept is where you intersect with the axis. That means anytime you intersect with an axis, that means the other coordinate is 0. An x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. Let's suppose, for example, if we have, 2x plus 3y equals 6. If they ask you from this one, what is the x-intercept, set, that means you set x. That means you set x. Okay, that means you set x equal to, no, you set y equal to 0. All right, if you set y equal to 0, you can solve for x. So that means you have 2x plus 3 times 0 equals 6. Now, because 3 times 0 is 0 and 2x plus 0 is 2x, you end up having 2x equals 6. You divide both sides by 2, so x is 3. Now, because y is 0, if you put both of your coordinates onto the points, x is 3, y is 0, one of the coordinates is 0, we call that intercept. But if it's the second coordinate that is 0, we call it x-intercept, because you have a value for x but not for y. For the same equations, if you set x equal to 0, then you solve for y. That means you have 2 times 0 plus 3y equals 6. 2 times 0 is 0 plus 3y give you 3y equals 6. If you divide both sides by 3, then you end up having y equal to, remember, we set x equal to 0. So in our point, the first coordinate is 0, the second coordinate is a non-zero number. Of course, it could be 0. That means the intercept is at the origin, but in this case, that's not, all right? Because the second coordinate is 2. Then we know this is the y-intercept. So we said this is y-intercept because x is 0 and you find something for y. But in many cases, they would give you the graph. They would give you a graph like this one, and they said, oh, what is the x-intercept? All right, let me ask you, what is the x-intercept here? We're gonna do it. Remember, where y is 0, x is equal to something, that means you intersect with the x-axis. Yes, thank you, because we see x is -3, that y is 0. That's why we intersect with the x-axis. Where do you think you intercept with the y-axis? We're gonna call it y-intercept. Yes, x is 0, y is 5. Sometimes we give you the regular equations and ask you to find the intercept, or sometimes we give you the graph and ask you to find the intercept. All you need to do is look in some graph, you might have more than one intercept, especially when you have a graph that is not linear. Like, this graph is a straight line. That means you only have x power 1. But if x is power 2, it's a parabola, your shape, then there is a possibility that you touch the x-axis twice. Then you're gonna have 2 intercepts. If your equation has x power 3, there is a possibility you have 3 intercepts. So it all depends of the exponents of the degree. All right, it's all depends of the leading degree. All right, of the equations. All right. Why do we do all of this? Any idea why you think we're doing all of this? Well, when we graph, it's because sometimes we don't want to write a big giant report, okay? Graphs help us to just take a look and have an idea if we make profits or if we have lost, right? So if it's tell us how the market value, the stock market is how it is for the day, that's different examples, okay? Now, lines are often used to illustrate trends over time. So measures of time, such as months or years, frequently appears on the horizontal axis. Amounts are generally listed on the vertical axis, and points are drawn to represent the given information, right? So you can form the graph the graph is formed by connecting the points with line segments. Okay, so we said the line segments displays information on the first quadrant of a rectangular chord in the system. You just need to connect the points, all right? So mathematical models like this one. This is a mathematical models in this examples. The process of finding formulas to describe real-world phenomena is called mathematical modeling. So such formulas, together with the meaning assigned to the variables, you call it mathematical models, right? So these examples right there tell us divorce rates are uh, considerably higher for those who marry younger. But education may also play a role in the longevity of marriage. The equation D equal 1.8 times n plus 14 models the percentage D of marriages that end in divorce after n years when married with a higher school diploma but no college education. So what they ask us to do in these examples, is simply describe the percentage of marriage ending, um, in divorce after 15 years for higher school graduates with no college. All right. So for example, like this one, all right, the first thing we're gonna do, is identifying what we have as a mathematical model. So we see, if I make this one a little bit smaller, I'm gonna put it smaller, okay? If it's okay with you, let's put it smaller. I'm going to consider this one like this one if you have no problem with that. So again, I'm gonna go and show it here, okay? In this example, so you see that we have you have an equation. So D equal 1.8 times n plus 14. Okay. So when I see that, the first thing that come to mind, what are those letters? Because the letters represent variables. What D represent? The good news, they already told me D represent percentages of marriage that end in divorce after n years. That means n is the number of years. But look at that. When they asked me that question, they said determine the percentage. That means determine the percentage of marriage. That means D. Okay. That's A in divorce after 10, 15 years. So that means this is N. So they ask me to find D when N equals 15. All I have to do is plug, if we know N equal 15, that means D, percentage of marriage ending in divorce, equal 1.8 times 15 plus 14. Order of operations, what you do in order of operations, if you remember, you do 1.8 times 15, okay? That's the first thing you do. You do D equal 1.8 times 15 give you 27 plus 14. Remember, never add before you multiply, okay? So 27 plus 14, okay, give you 41. So percentage is of marriage ending after 15 years. Percentage, or I can say 41% of marriage, 1M, and in divorce after 15 years. Well, if you only have for those with high school diploma with no college degree, right? Right? For high school, graduate with no college degree, right? So that's it. You know, one thing you need to pay attention here is the fact that you can use equations to solve real life situation. All right. So when we use the appropriate formula to find the percentage of marriage ending in divorce after 15 years, when educational attaining is in high school or higher, you know, you just need to substitute the number of years in the equation to find it. They could give you the percentage and ask you the number of years as well. So the models we have here indicate that um, 41% of marriages ending in divorce after 15 years for those with a high school diploma. So when you think, you know, most importantly, we don't do for a bachelor degree, we don't do for master's degree, we don't do for bachelor, for a PhD, or we don't do for associate degree. It's just an example to explain how we can relate equations or inequalities to real world situation. All right. I'm gonna stop here for section 1.1, graphs and graphing utilities. Remember, if you don't have a calculator, I strongly advise you to get one ASAP, especially TI-83 or 84. In a different video, we're going to continue with this chapter, uh, especially section 1.2, linear equations and rational exponents. I'll see you in the next video. Hope you have fun with this one. Take care.